Well, hello, dear students. This is Adam Briggle, recording a lecture here that is intended for both my modern philosophy and my social and political philosophy courses this spring semester. I think going forward, I'll probably do a little something different for each class, but because the purpose of this talk is to introduce us to our case study, which is carbon dioxide removal, or CDR, I thought it would be okay to bring us together, and it'd be nice if we were in the same room, actually synchronously together, and we could all say hi to each other. But here we are virtually, asynchronously. You can imagine, though, that we're in a nice college classroom. And again, these lectures are part of your grade. 25% you're on your honor in terms of grading this. So at the very least, this should be an easy way to do well on the course is to watch and listen to these lectures. But I'm hoping more than that, you actually get something out of this. You learn something, and it enriches both of our topics, modern philosophy and social and political, by being a case study in these different versions of philosophy. So that's that. I mean, I hope basically this is a part of the value of being at research university is you get to interact with professors and learn about what research they're doing and how it connects to what you're learning in the classroom. So that's that. Now, I don't have my camera on because I read recently that the environmental footprint of streaming the video portion of like Zooms is much higher than not having your video streaming. So I thought I would try this and we'll just see how it goes. Okay, I have about 15 slides. I'm hoping to keep this to about 20 minutes. I realize I haven't started my timer, so I don't actually know how well I will do with that goal. But what you can see is the outline here. As I'm talking at you, I'm putting my timer on now so that we can kind of keep an eye on this and not get out of control. Today, I want you to walk away from this talk knowing what we're going to be talking about and why it's important. And the way I'm going to do that is by situating carbon dioxide removal, or CDR, within the context of climate change. So we're going to talk about climate change briefly, ways to define that problem, and then we'll be able to, well, I think we'll be in a place to understand why we're talking about CDR, because it's one of the possible solutions or alternatives that's available to addressing climate change as a problem. And it's just something I'm really interested in. Now on this slide, and I was supposed to share the noise, the computer sound. Hold on. Let's see, share computer sound. Okay, I'm going to try to fix that. So on the slide now, it just has a couple images of books that I've written. I don't consider myself an expert really in anything because I'm a kind of interdisciplinary guy. But if you're wondering, well, what gives Adam the right to talk about this stuff? Well, I've been thinking about it for a while, and I really enjoy researching it. And I've got some bona fides in the area, I guess, if you count writing books about this stuff to be a sign of credibility. Well, there you go. Let's jump forward. Okay, now I want this is a slide. And again, I don't know if it shared the computer sound, but now we're on the slide of the greenhouse effect. And in some ways, climate change is very simple. Just to narrate this little animation, you've got solar radiation coming into planet Earth. And if we didn't have an atmosphere, of course, we would be freezing cold or burning hot. The atmosphere helps to moderate the temperature. And it does that in part by absorbing and re-radiating heat back to the Earth. And really the primary mechanism that does that are these greenhouse gases that are in the atmosphere. So the greenhouse gases, the proportion that we have in the atmosphere, help to determine the climate, which is really the long-term average weather of the planet. And then concentration of greenhouse gases do so primarily by establishing temperature regimes around the planet. So if you change the amount of greenhouse gases in the atmosphere, if you increase them, generally you warm the planet. And that's why we have this term global warming. We talk about climate change though because the warming that happens as we put greenhouse gases in the atmosphere is not the only impact on our climate. So it's a more general term to say, we're not just talking about warming, we're talking about all of the cascading changes that can happen through this greenhouse effect. Should be no surprise to you that The biggest driver of climate change is our use of fossil fuels. I'll say a bit more about this. When we burn fossil fuels, coal, oil, and natural gas, we emit carbon dioxide and methane in some cases. If you have natural gas leaks into the atmosphere, these are both greenhouse gases. People tend to talk mostly about CO2, carbon dioxide, because it is the biggest contributor. It's not the most powerful greenhouse gas by molecule, but there's just so much of it that we're emitting because of fossil fuel consumption, and to a lesser but still significant degree, land use changes like deforestation and industrial agriculture. There are a lot of impacts associated with climate change, which is why we're worried about it. Okay, basically, if you keep going the route we're going on, you're going to tip the planet into a different climatic regime, which may be uninhabitable or at the very least not as well suited to human civilization as we have it now. So you talk about saving the planet. In many ways, look, the planet will always be here, and you always have different ecosystems and species that will flourish under whatever climatic regime we have, but it may not be suited for our flourishing. So we're talking about the habitability of the planet for human civilization. That's why I think it's got to be one of the most important issues of the 21st century. So I put on this slide what we're looking at here. This is a picture of a glacier that has receded dramatically since 1941 to 2004, the two images you see. Just to say, it's not just about glaciers, okay? It's about a whole bunch of things. You're talking about potential migration of tropical diseases to places they haven't been, impacts on ecosystems and species, impacts on our agriculture and food systems, impacts on our freshwater systems, and just in some areas getting too hot to be habitable. These are all the potential negative impacts of climate change, which is why we want to do something about it. You can represent now. I don't know why I put to share the sound on my computer. But anyways, I switched slides now. This is an image of the parts per million of CO2 in the atmosphere from 1960 to about 2015, just to show you that although it fluctuates annually, primarily as the northern hemisphere goes in and out of its fall, spring, winter, summer seasons, it's decidedly going up and up and up. Back in 1960, parts per million was around 320. Now we're up closer to, I haven't checked in a little bit, but it's over 400. It might be about 410 or so. And again, as we increase the concentration of CO2 and other greenhouse gases, it has this warming effect, which has this broader climate change effect, which has these impacts. This is another slide. I'm on the next slide with a longer look. Again, the Earth is 4.5 billion years old, and climate always changes, right? We're worried about anthropogenic climate change, which is happening on a very rapid rate, geologically speaking. And it's happening at a time when we have all of these infrastructure in place that really depends on the current climatic regime. So you can look over the last at least 800,000 years, we've never seen carbon dioxide levels as high as they are now. And they have spiked precipitously since even just the 20th century. So we're making this rapid change to the global climate system. Next slide is an image that's just, the point of this image is to say it's messy. And I say on the top, climate change is not an issue, really. It is a kind of condition that we're in. You could say that climate change is one of the intersectionalities of a whole bunch of issues. And it's tied up with so much stuff. You can talk about systemic racism and ethnocentrism as being tied up with climate change and environmental injustices. We can talk about capitalism and our systems of production and consumption, trade, agricultural systems. I mean, you name it. Climate change isn't an isolatable issue. It is this condition that is impacted by and is impacting all sorts of things. And it makes it really hard to think through. Okay, next slide is a graphic representation since 1751 of our CO2 emissions globally. Something on the order of 2.5 trillion tons of CO2 have been emitted in the industrial era. Uh, we are currently, you can see it's growing and accelerating. We're currently emitting about 40 gigatons annually, globally. 40 gigatons is the same as 40 billion tons. A gigaton, a billion ton. The other thing I've noted here that should be no surprise to you, there's disproportionate responsibility for these CO2 emissions. I've highlighted, for example, the United States, 328 million people. A significant chunk of cumulative CO2 emissions, all the CO2 sitting up in the atmosphere, has come from these 300 million people. You know, it was only 150 million people, so 100 years ago or so. Africa, with 1.2 billion people, has a barely noticeable slice of this emissions problem, right? So you have what the IPCC would call common but differentiated responsibilities to do something about climate change. Common because we're all in this together. There's just one planet. But differentiated because, let's not kid ourselves, some people, some nations, some corporations have been more responsible for these emissions than other people. And indeed, some people have primarily benefited from this situation, and many other people have, well, either been marginalized or even been harmed by this situation. Next slide is a chart just showing the acceleration of CO2 emissions. So if you want to picture this in your mind as like a pie chart or something, if you divide all of those, what did I say, 2.5 trillion tons of CO2 emissions into a pie with 4 equal slices, it took from 1751 to 1968, that's over 217 years, to emit the first quarter of our greenhouse gases. It only took 20 years to emit the second quarter, 17 years the third quarter, and only 9 years the final quarter. In other words, we are accelerating our emissions at a very time, of course, we've known really since the 80s and 90s about climate change. We've known about the need to actually start reducing and eventually eliminating these emissions. That brings us to the problem formulation. This is our next slide. It's got goals, trends, conditioning factors, projections, and alternatives. This is a way to think about problems. I often teach this little framework. It's very simple, but I think powerful. The UNFCCC is the United Nations Framework Convention on Climate Change, which is really the go-to place when it comes to authoritative science and policy relevant science on climate change. Now, the UNFCCC says the goal is to stabilize greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. So I want to take that as our goal. I think that's pretty well phrased, right? And what are the trends with respect to this goal, right? So we're talking about greenhouse gases. We want to stabilize them. Well, are they stabilizing? No, we've already seen that, right? CO2 emissions are rising. So when you have trends that point away from your goal, you have a problem. Okay, that's just a very simple way to put it. What are the conditioning factors for these trends? In other words, what's causing CO2 emissions to go up? Well, I've talked in a direct sense. You could say it's fossil fuel consumption, industrial agriculture, and deforestation and other land use changes. Those are the sort of direct drivers. But you can always ask, like a good 3-year-old, well, why is that happening? So what are the indirect drivers? You can go down a chain of causality. And I think eventually gets to something like a society or a way of being in the world that's premised on production and consumption and growth. And you could maybe chalk that up to capitalism, Western civilization. There's different ways to theorize this, and I think those are super important and interesting. Okay, now what are our projections? What's going to happen in the future if current policies are followed? So just say status quo. Will the problem take care of itself? No. Likely, our policies are insufficient to keep us from warming at a 1.5C or a 2C target. Now, just a quick mention about that. Scientists estimate that we have already warmed the planet on average 1 degree centigrade or Celsius since the beginning of the industrial era. They further think, although there's a lot of debate about this, but I think it's a general consensus, that it would be a really smart idea to limit further warming to another half or 1 degree C. So in other words, if we could limit to 1.5C or 2C total warming since the industrial era began, that would be a good idea because the higher we go with greenhouse gases and the temperature increases that are driven by that, the more risks we create. And so our targets really are to try to cap warming at 1.5 or 2C if we can. It looks like with current policies and even pledges of things people want to do, we're not going to hit that 1.5C target. It's extremely aspirational, to put it mildly. Maybe we could hit the 2C target, but we have to do more than what we're doing. Right? So that's another way to frame a problem. If current policies are inadequate to get to the goal, you have a problem. So here we're getting now finally to our case study, carbon dioxide removal, because it's one of the alternatives. So if you have a problem, you need to do something different. What should we do about climate change? And there's lots of debate about that. Basically, we have to decarbonize our energy and agricultural systems, and we have to do it rapidly. But it may be, and here's the kicker, it may be we waited too long to just switch over to solar panels and wind turbines as a sole solution. It may be that we have too much CO2 that's going to get in the atmosphere, and we have to draw some of it out of the atmosphere. And that's where carbon dioxide removal comes in. That's what I want to get to. So this is the last part of the talk, is going to be about different ways of framing the problem, getting to CDR. I switched slides now. This is a 2015 National Academies report. I just thought this was really interesting. You talk about direct and indirect drivers and what we can do about those. This is a neat little graphic that just shows arrows starting from top to the bottom. And I think this is about right. What's at the root cause of this is a desire for improved well-being. Now, I think that desire actually is framed through our modern social political lens. That's what I want to get at with these classes. It's one of the things I want to get at. Because I think the way we think of well-being is very materialistic and consumer-oriented and productivist. And I don't think all peoples in all times have thought about well-being in this way. Okay, that's the root philosophical interesting point for us to get to. So what could we do about that? Well, we could use less stuff, right? So they have these arrows that's like the root cause, and then they have these little arrows coming in from the side that says, if we could address that level of the cause, what would we do? Well, we buy less crap, right? Or we take fewer international trips. Okay, well, because we want improved well-being and we understand that in a consumerist way, we consume goods and services. Well, we could address that by making the production of goods and services more efficient, right? As we consume goods and services, we consume energy. Well, we could have low carbon energy then, right? When we consume our energy, we have CO2 emissions. Well, we could capture those. Here we're getting to our case study. What if we capture those at the source? So in other words, right at the tailpipe or right at the smokestack, you scrub the CO2 out. Well, we haven't really been doing that very well. We have a lot of CO2 in the atmosphere. Well, now we might have to have carbon dioxide removal directly from the atmosphere, right? In other words, we've been spending 250 years taking carbon out of the rocks and putting it into the air. Now we have to reverse engineer that process and take it out of the air and stick it in the rocks. Okay, that's what we're talking about. Okay, now that's one way to think of it. Let me switch slides. This is more the stereotypical way of putting it. When you say, okay, Adam, there's a problem with climate change because the trends and the projections don't look good in terms of what our goals are. What are the alternatives? Well, there's a lot of alternatives. How can we organize the alternatives? Well, there's really three kinds of actions that we can take on climate change. And this is what this little graphic here, this is a slide with our three kinds of actions. You have mitigation, geoengineering, and adaptation. Mitigation addresses our impacts on the climate. Adaptation addresses the climate's impacts on us. And geoengineering directly interferes one way or another intentionally with the climate system. That's the way to think about this. So some examples of mitigation. The biggest one you'll think of is solar panels, wind turbines, nuclear energy, low carbon energy, right? But there's lots of things to incentivize that move. You can tax carbon. You can have big budgets that invest in low carbon energy sources and all this stuff. You can prohibit the construction of fossil fuel infrastructure like pipelines. I would consider all of that mitigation. In other words, you're reducing the emissions of CO2 in the atmosphere. Now, what we're interested in is geoengineering. Let me pause on that for a second. Let's do adaptation. Adaptation is to say, look, the climate is always changing, and unfortunately, it's going to be changing because of our impacts for quite a while, almost regardless of what we do. So it's a smart idea to build resilient infrastructure and to think about how we can build capacity for people to literally weather the storms, as it were, of climate change, which means we need to address poverty and we need to address inequalities. We need to invest in communities that have been marginalized and that are vulnerable. Right? And that's a lot of good adaptation stuff to be done. Now, all of this is interconnected. But what we're going to focus on primarily here is this geoengineering bit. And there's really two kinds of geoengineering. One, which is kind of crazy, but actually is starting to happen, is solar radiation management. Now, there's different ways to do this, but the one that's getting the most traction right now is releasing sulfates into the stratosphere to mimic what happens when a giant volcano explodes, which has a way of cooling off the planet because these sulfates reflect solar radiation. Okay? We won't talk about that so much, although I think it's freaky and cool and interesting, and we can always discuss it if you want. The one I'm interested in is carbon dioxide removal. And I list a few of them here. But as you can imagine, that means the stuff that's in the atmosphere, we pull it back out. Right? That's a form of geoengineering. Now, there's another way to think of this. I just switched slides. It says our carbon budget here. Imagine that we have a carbon budget to stay within that 1.5 or 2 C temperature target. Well, imagine that we have this budget, which is like a bucket. And so there's only a certain amount of carbon that we can stick in the atmosphere before we will overflow our bucket and we'll go past those temperature targets. And we are very close to filling that bucket. We only have something like 9% of the carbon budget left. This depends on how I calculate it. My middle of the road estimate is we have about 715 gigatons remaining before we hit like a 1.75 C target. 715 gigatons at current rates of consumption is about 17 years. Okay, so the clock is ticking fast. Some people say it's less like 10 years. Other people say it's a little bit longer, but it's in the scheme of things not very long. So when you have a bucket that's filling up too fast, you have three options. One, put on your boots because you're going to get wet. That's adaptation, right? Just figure out a way to live with it. Two, you can turn off the spigot. That's mitigation, right? Stop putting carbon in the atmosphere. Three, you can drill a hole in the bottom of the bucket, and that's carbon dioxide removal, or what's called negative emissions. In other words, the stuff that's already in the bucket, we take it back out. Okay. Now, maybe you could say it's like putting a spoon in the bucket or something, but I like drilling a hole in the bottom of the bucket. Now, last couple of slides. Do we need to do CDR? I mean, isn't mitigation going to be enough? Well, probably not. The IPCC, in its 2018 report, I have a bunch of text on this slide to just give you the gist of it. They think, and again, this is so hard to predict because it's so complicated and it depends on human action, which cannot be predicted. But they think we're likely going to need CDR to hit a 1.5 target or even a 2 target. Somewhere on the order of 100 to 1,000 gigatons of CO2 we're going to have to pull out of the atmosphere. And again, 1,000 gigatons would be equivalent to something like half of all of the industrial emissions we put into the atmosphere. 100 would be equivalent to about 2.5 years worth of our current annual emissions. So significant, right? This isn't the only alternative. It's maybe not even the biggest one, but it is a significant one that's under consideration. Last slide here, and then I think we will have accomplished our objective of getting a sense of what CDR is in the scheme of things and why it's important to think about. And that's just to say, look, there's really two kinds of CDR. So you have three kinds of solutions, right? Mitigation, adaptation, geoengineering. Then you have two kinds of geoengineering, solar radiation management and CDR. Okay. Now you have two kinds of CDR as we go kind of down this decision tree. And I don't particularly like these terms, but they're pretty intuitive. One is natural. Hey, guess what? We have a thing called trees that scrub carbon out of the atmosphere and put it into the biosphere, right? So you can have reforestation, that is to plant trees where they used to be recently, or afforestation, which is to plant trees where they haven't been in a long time, say. You can also even have other ecosystems, certain grasslands up in the steppes of Russia, for example, actually store more carbon than trees would up there. So some people are actually tearing down trees to get grassland to grow in an effort to store more carbon. But we'll just call all of that afforestation or reforestation. And then finally, you have these technological approaches to CDR. And the last thing I'm putting up is a graphic here. This isn't really comprehensive, but this is close enough. Just to show you there's at least three main kinds of technological ways of capturing, of doing carbon dioxide removal. One is usually called CCS, carbon capture and sequestration. And this is at the point of combustion. So imagine those big power plants that burn coal. Well, you put a scrubber on the smokestack where the emissions are coming out, and you separate as much of the CO2 as you can. And then you either inject that CO2 back underground so it becomes part of the lithosphere again, or you inject it back underground where it will hopefully stay in a way to actually get more oil out. So that's called enhanced oil recovery. Now you're probably thinking, why would you do that? Because we're trying to capture the emissions. Well, I kind of agree with you. But if you could store some CO2 in the process of digging up yet more oil that will create more CO2, at least you've offset some of those emissions, right? So in other words, with all of these techniques, what are you going to do with the CO2 you capture? You can stick it under the ground and leave it there, or you can use it in different ways. In fact, some people are saying we should use this CO2 to make a carbon neutral concrete, right? So I think that's part of the weeds of the debate we're getting to. The next one here on this graphic is DAX, or direct air carbon sequestration. This would be just putting up giant fans basically out in the middle of nowhere. It doesn't have to be at a power plant. And just with the atmosphere around you, pulling the CO2 out of it and then sequestering it. And then finally, you have what's called BECCS, bioenergy carbon capture and sequestration. This one is talked about the most in the IPCC. Basically, what you do is you grow plant material in one form or another. You combust that to make energy. But then, like in the first example, you capture the CO2 from that combustion and you sequester that somehow. So it's all kind of variations on a theme, really, but they're important variations. All right, I tell you what, I yacked on too long. I hope this is a good introduction to our case study. Of course, we'll be talking about it all semester. Hit me up with questions if you got them. And until next time, may the force be with you.